Alright, this is Math 111 OLC Winter 2012, Unit 1. This is our third video lecture of 3. We're going to be covering in Unit 1. We're going to cover Section 1.7 in the text, entitled Using Equations to Solve Problems, more familiarly known as word problems. Alright, basically the text covers 6 word problems and examples with beautiful pictures and beautiful text, and what I'm going to do is work with you through 5 of these 6 problems in the text. So get that text out, and we're going to be working heavily with the text today. The first one I want to talk about is example 2. On the bottom of page 76 this problem starts. So please get your book out, read through the problem statement, familiarize yourself with the problem statement, and pause if necessary, and come back when you're ready. Please pause now. Alright, I'm going to read through the problem here before we go on. Example 2, triathlons. A triathlon includes swimming, long distance running, and cycling. The long-distance run is 11 times longer than the distance the competitors swim. The distance they cycle is 85.8 miles longer than the run, and overall the competition covers 140.6 miles. Find the length of each part of the triathlon and round each length to the nearest tenth of a mile. Alright, so what I'm going to do here is show what I call a let statement before I go on. Let me get it together here. I'm going to, we have to find out the distance of the swim, the distance of the run, and the distance of the cycle, right? So let me put that down. I'm going to let x be the swim distance, and I'll abbreviate that with swim is x. The run, and then the cycle distance we'll talk about in a minute. Oops, spelled that wrong. Cycle. Alright, well, what's going on in this problem statement? Notice everything is described in terms of the swim, right? It says the run is 11 times longer than the swim. Alright, so I can easily state then that the run is then 11x. If the swim is x miles, the run is then 11x miles, and then it tells me the distance they cycle is 85.8 miles longer than the run. Well, that is indirectly described in terms of the swim. So I can then say, well, if I just add 85.8 miles to that, I can easily describe the cycling in terms of the swim. Alright, so they tell us overall, the competition covers 140.6 miles. Alright, so I can easily make an equation out of this. I can say that the swim distance plus the run distance plus the cycle distance has got to equal the total distance, right, of 140.6 miles. Alright, and we do have some decimals here. But I think armed with a calculator, we can cover this pretty easily. Let me go ahead and combine some like terms. Notice all my variable expressions are on the left, and these are all like terms. Of course, I can combine them, and I'll get 23x plus 85.8 equals 140.6. All right. Alright, what I'm going to do now is, again, solve for x. I'm going to subtract 85.8 from both sides. And we'll use a calculator to take away some of the drudgery here. I'll then get 23x. Of course, the numbers cancel out on the left-hand side. Equals 54.8, my calculator tells me. Alright, and again, the goal is to solve for x. So just like in section 1.5, I'll divide both sides by the x multiplier, and I'll get 20, let's see, the 23's cancel here. I get x equals 2.38. I'm going to say, they do say to round off to the nearest tenth, So I'm going to say x is approximately 2.4 miles to the nearest tenth. Now that's the swim. Now again, our goal is to find all three of these lengths, or sub-lengths, running and cycling. Well, then it's just a simple matter of multiplying and adding. 11x, remember the run is 11 times that, so 11x is going to be, let's see, 12, call it 26. And so 11x times 11 times 2.4 is going to be 26.4 miles. And I'm going to say that's going to be the run. And so 11x plus 85.8. Just add to that previous value, 85.8. It's 85.8 plus 26.4. 112.2. And that sounds about right. If you watch triathlons on TV, that sounds about right. So, there's the cycling portion. Alright, now, there may be some mild discrepancy regarding the book's values. I think the book says 112.0 for the cycling. The book says 26.4 for the miles, but this will attribute that to round-off error. And I claim these are wonderful answers, rounded off to the nearest tenth for all those triathlon sublengths. Okay? Alright, that's example 2 on page 76. Next, I want to talk about example 3. Example 3 is on page 77. And again, please familiarize yourself with the problem statement before we go on here. So please get your books out and read the problem. Example 3, page 77. Please pause now. Alright, the example 3, they talk about travel promotions. The price of a 7-day Alaskan cruise, normally $2,752 per person, is reduced by $1.75 per person for large groups traveling together. How large a group is needed for the price to be $2,500 per person? Alright, so hopefully we've seen this situation before in our lives, where basically you're getting a discount for the number of people participating in this event. Alright, what I'm going to do, since our final price depends on the number of people participating, and since that's what we have to find out, I'm going to let x equal the number of persons participating in this trip. Okay? Now the ticket price starts at $2,752 and goes down $1.75 every time somebody's added on to the trip. Alright, so I'm going to subtract a multiple of 1.75, right? Because I'm taking off 1.75 for every person that joins. So I'm going to say 2,752 minus 1.75x, where x is the number of persons participating in the trip, and we want to keep doing this until we reach a price level of $2,500 per person. Alright, so there's the setup. It's a simple let statement, a simple setup of the equation. Really not too bad. Of course, we're going to use a calculator to help us out here. I'm going to subtract 2,752 from each side. Of course, cancels out on the right. And I'll get 2,500 minus 2,752. Of course, that's negative 252 is left, equaling minus 1.75x, where x is the number of persons participating. So 5 there. Alright, of course, now I'm going to solve for x, and I can do that easily by dividing both sides by minus 1.75. Alright, the minus 1.75s cancel out on the right. I get x all alone on the right. So negative 252 divided by negative 1.75 gives me a final return of 144, where X is the number of persons. So I probably should label that quantity. 144 persons should be involved in this trip if you want the price to go down to $2,500. Alright, that's example 3 on page 77. Excuse me. Next I want to talk about example 4 on page 78. Alright. Again, take a minute to familiarize yourself with the problem statement and come back when you're ready. Example 4, portfolio analysis. A college foundation owns stock in Kodak at $26 per share, Coca-Cola selling at $52 per share, and IBM selling at $103 per share. The foundation owns an equal number of shares of Kodak and Coca-Cola, but 5 times as many shares of IBM stock. If this portfolio of stocks is worth $415,100, how many shares of each stock does the foundation own? Alright, so what I'm going to do, again, the first thing I'm going to do after I read the problem, of course, is write a let statement. I'm going to let X equal the number of shares of Kodak. Hang on. Shares of Kodak equal X. Well, again, I pick X to be Kodak because I notice all the other share numbers, either directly or indirectly, are described in terms of the shares of Kodak. Alright, the shares of Coca-Cola, which I'll abbreviate as CC, well, that's the same as the number of shares of Kodak, so I'm going to let that be X also. Now, the problem does tell us the shares of IBM are 5 times the number of shares of Kodak. Right? So I'm going to let that be 5X. Alright, so the best we can do at this point, we can't give particular values of the number of shares, but I can tell you how many there are in terms of shares of Kodak. Now, one thing we need to notice here is that the Kodak shares are worth $26 per share. Let me make a note of that. The shares of Coca-Cola are worth a bit more. Those are $52 per share. And the IBM is the priciest of all. The IBM shares are $103. Alright, what I can do is use this information to squeeze out an equation, because I know the total portfolio, the value of all the shares of stock put together, is $415,100. Alright, so it's an easy matter to say, well, the value of the Kodak stock, well, you've got X shares at $26 a share, so 26X is going to be the value of the Kodak stock. Plus the value of the Coca-Cola stock. I've got X shares of Coca-Cola valued at $52 per share, so that's going to be 52X is the value of the Coca-Cola portion of the portfolio. And of course, then you've got 5X shares at $103 per share, plus 5X times 103 is going to be the value of the IBM portion of the portfolio. And all these added up are $415,100. Alright, so with a clear statement, it's an easy matter to set up an equation and solve this, much like the techniques we used in section 1.5, combining like terms, etc. Well, I don't know if this is worth a whole nother line of code. Clearly I'll need to multiply these expressions, 5x times 103 is going to be, well, I've multiplied the numbers, the coefficients first. 5 times 103 is 515x equals 415 100. Alright, it's a simple matter now to combine these like terms. I get 593x equals 415 1. Now I'll divide both sides by 593, and I'm hoping we get a whole number out of this. I get my calculator out, and yes we do. I get x equals 700 shares of the Kodak stock. Alright. Then, well, what about the Coca-Cola stock? Remember, there were the same number of shares of the Coca-Cola stock. And then, of course, 5x is the number of shares of the IBM stock, and that I can do in my head is 3,500 shares of IBM. Alright, so there is your final answer, boxed real nice and simplified real nice. Okay? Alright. I want to talk about next example 6. On page 81. Now, I think this is going to be enough. I did originally say I was going to do 5 examples. I think 4 is going to be enough here. Example 6 is the last one covered in this section in the text. Example 6 on page 81. Please familiarize yourself with the problem statement, and there's a diagram to read, so please pause and turn there now. Alright, a man has a 50-foot roll of fencing to make a rectangular kennel. If he wants the kennel to be 6 feet longer than it is wide, find its dimensions. Alright, so rectangular kennel. First thing I'm going to do is draw a rectangle. Basically geometry-based word problem here. He wants the kennel to be 6 feet longer than it is wide. Well, of course, I'm going to let W be the width then, and W plus 6 then be the length. Okay. Now we've got a total of 50 feet of fencing. Well, they describe it as a 50-foot roll. 50-foot roll. Let me make that look a little nicer. And the author describes the available fencing as a 50-foot roll. Alright, so basically we are going to wrap a 50-foot roll around this rectangular partition, okay? Alright, so how wide does the fence have to be? They're asking what are the final dimensions of the fence, namely the length and the width, right? Now, of course, in a rectangle, opposite sides are equal. That's by definition. And I can say, well, I've got 2 W plus 6 lengths plus 2 W lengths, and I know overall I've got 50 feet of fence to cover it all. So if I set that expression equal to 50, I think it's going to be not too terribly difficult to solve this equation for W. And as we did in section 1.5, I'm going to use my techniques of linear equation solution, multiply this expression W plus 6 through by 2. Alright, combine like terms. 4W plus 12 equals 50. Now that I've completely simplified on both sides of the equation, I'm going to divide. Hang on a minute. turned around there. I'm going to subtract 12 from both sides and then divide by 4. Okay. So 4w equals 50. If I divide both sides by 4, well, 50/4, the book tells us, is 9.5 feet. So I suppose here it might be prudent to use a calculator. Alright, so if the width of this rectangular kennel is 9.5 in feet, remember we've also got to find the other dimension, namely the length dimension. And if I add 6 to 9.5, of course I get 15.5 feet. So there's a nice box simplified answer to this example. Alright, so that's 4 of worked out textbook examples. And again, please complete all homework and check your answers in the homework solutions PDF files that are contained in the Unit 1 folder. And when you've done all the homework and checked all your answers in those PDF files, then you're ready to take the online exam. The online exam will be posted Thursday by 5 p.m. That's Thursday, December 20th by 5 p.m. Alright, this concludes this Unit 1, Section 1.7 lecture. That is all.